Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Sorry about that rocky start. I have no idea what happened to make my audio settings change in the way that they did, but it looks like I've got everything fixed. Please let me know if I'm still coming out in one ear or if there's this annoying high-pitched ringing in the right monitor or either monitor. Still have no idea why that happened, but I think we're okay now. Anyway, so last... Yeah, I might be at like half volume. Oh, fudge knuckles. This might not work as well as I hoped. Ugh, I'm so frustrated by this. Because I can clearly see how I'm not at full volume here. Actually, I can probably fix that if I just gain it up now. Check. Should be at 12. Check. All right, that should be better for my volume. Okay. Good, now I think we're fixed. Okay, no idea how that happened, but I have been plugging and unplugging in audio interfaces for the last week or so, so I guess I'm not that terribly surprised. Anyway, we're all good. The last few weeks, what I've been working on is moving our 64K synth over to using SSE instructions rather than FPU. I don't want to go into too much detail about what that means because, again, this is like the third week that I've been working on this. But basically, where we're at now is that this seems to be working. Got the whole synth onto these other POW instructions that we use for that, and then did our own polyfill for cosine, which I might inline. So right now, what I want to do is just some cleanup now that everything's working. Just so I can kind of get this into the form that I actually want it in. And then when that is starting to work, I want to disable denormal stuff by disabling some SSE flags. And then I want to start doing a bunch of testing, particularly with and without these changes to see if we're faster, if the code is smaller, those kind of things. So that's basically where we're at. If all this works, then I should be heading into this week with this part done, and then I can focus on actually preparing the music disc for our release. And that should really help us out. I think I still don't want to announce when we're going to release this, but it's going to be soon if all the stuff works out well, which I think it should. Kind of somewhat news. I actually have this next week off work. I don't think I'll be streaming more than usual this time, but I might make a lot of progress on this, so we'll see if I end up turning the camera on or not. Might be some midday streams in the coming week, but I don't think so far, but we'll see. Anyway, let's just get back to work here. The first thing that I use here, I think it's in down here in helpers. We generate some stuff for our sine table, and we use cosine here. And I actually want to not use math.h's cosine. I want to use our own cosine like we did with POW here. So the first thing I'm probably going to do is just move this into its own function there so that we don't have to do any weird linkage stuff. And then it's clear that we're calling our function rather than something that's actually compliant to that interface. So if you do like FPU cosine, we can call it, which fits the other ones that we have here. The other thing, though, is that we need to move stuff into the right registers here and then have the appropriate prologue and epilogue for this function, which changes a little bit because of things. Because this actually, I think the calling convention of this function is that this will still use FPU, which is fine, even though we're going to use SSE everywhere else. So I think that's just this. We don't need to do move SD here because we can just do X, load that onto the FPU and do cosine. I don't think we need to pop anything because that should be our return. So that should work. In fact, if I just build this, that should be okay. Seems to be. Philadelphia, do you compile in 32-bit mode? Yeah, all this stuff is 32-bit. All the 64K stuff we do is 32-bit. Which mostly has to do with compatibility with the packers that are available. By the way, hi to guys in the chat. Thanks for showing up and watching me and watching and helping me debug audio issues. Norm, SK Thess, Alkama, G Cyberlin, Freefall. Luna Sorcery. Dan MP87. Whister Tobe. Who else am I missing here? Philly Delsky. Think that's everyone? Yell at me if I miss you. Lila, how's it going? So yeah, so that should work. And then we basically have everything filled in for the stuff that we're missing. And I just don't care now about implementing the particular interface that we needed before, because this should just work. Next thing I want to do though is I want to get rid of denormals. For those of you guys that don't know, Zero Pent, I take it Norway is as hot as Sweden. Indeed it is. As you can see, I'm quite shiny today, and I've been skipping a lot of streams because of the heat. I've ordered an air conditioning unit, which hopefully will be here this week, but until then, I'm just going to be shiny and or skipping streams. Yeah, but basically denormals, the issue with them is that in the normal floating point representation, you generally have pretty good signal-to-noise ratio for most number ranges. However, when you get really small around 0, for example, or 0 in particular, you actually lose quite a bit of range when you get to really small values centered around 0. And so the way that that's actually fixed in the IEEE 754 floating point representation is there's a mode called denormal mode, and it actually happens when all the exponent bits are 0, I think. And what you end up with is effectively a number that's on most CPUs will actually cause a hardware trap that will trap in a microcode and then process the thing in a slightly different way, which basically means that if you're ever processing denormal numbers, it's going to be shit slow for just a small amount of accuracy around 0. Now, normally this isn't too much of a problem, but particularly with soft synths, this is actually a really big problem because you do a ton of floating point processing per audio sample, and at the same time you have a lot of feedback loops, which will make numbers that will tend to 0 over time. And that combination of things means that denormals happen all the time when you're doing soft synth programming. Previously, we got around this by just biasing numbers when we knew that denormals would come up. So we have these fixed denormal functions. And if we just go to the definition of these, we literally just add a tiny epsilon. You can often add and subtract this if you know that this isn't going to be optimized away. And that will bring the number out of denormal range and then bring it back down to where it should have been without just biasing in one direction. Ideally, though, we would not have to worry about these. And one of the advantages of SSE is that there's actually 2 flags in the control word that allows you to get rid of denormals. One of them is a flushed at 0 flag, which should, if I understand this correctly, whenever a floating point operation produces a denormal, that's in SSE at least, it will flush that to 0 on the output when it actually writes that out. And then the other one is the denormals are 0 flag, which is whenever a denormal number comes in as input, it treats it as a 0. So with those 2 flags enabled, globally, we should be able to get rid of denormals altogether and remove all this stuff, which mostly just helps us keep our code kind of clean. But also, there are probably cases in the synth that we haven't covered that would produce denormals that we just haven't seen happen in the wild. It'd be really nice to not have to worry about those kind of things. So that's one advantage to using SSE over FPU, because FPU doesn't have any way to disable these, which is kind of stupid. But that's how it is. Exactly. SKTS. Demo S. That'd be cool. Anyway, the way I'm going to do this is pretty simple. I'm actually going to make a different test project because I want to just isolate setting these flags here. So I'm just going to make a new project here. Actually, I think my SSE shiz project did this. Maybe it didn't. No, this is the wrong one. I think I have a float flags project. And here, I set up the FPU control word rounding stuff. I'm going to bump up the font size, by the way. Sorry about that. Anyway, this was just reading out the FPU control word and then doing some conversions, testing that kind of thing. And there's some other stuff too. But yeah, so if I run this, I think it doesn't produce any output. It just produces some output to a file. And the reason I did that is so I could run this within the context of the synth as well and get output easily. Let me go ahead and see where that was. should have ended up in that directory. Yeah, this out here. Basically producing this. So I'm going to do a couple things here. I actually want to keep this outputting the file just because I don't have to change that. But instead of the FPU control word, we're going to change what this actually does. I also don't really care about this rounding stuff. So, you know what? I'm just going to start a new project for this. And we're just going to be, instead of FPU shiz, will be SSE flags. FPU flags, SSE flags. Then I'll do all the normal starting project in Visual Studio crap. Whoops, there we go. And this should basically do the same thing. Let me zoom in for you guys. Good. We don't care about this conversion stuff. So I'm only really going to care about the bits here. I might try to do some denormal stuff though, just to be sure about this. But let me look at this. So we need, let's see, SSE control word bits. So I just searched that, and of course I found x87 SSE floating point assists in IA32, flush to 0, and denormals are 0. Okay, apparently there's a denormal control bit. That's new to me. In FPU even. What the hell? Oh, that's just for debugging. Catching a software thing for that. If I read that correctly. Which doesn't really help us. We want the SSE ones, which should be able to here. A hardware flush to 0 mode is possible, so we want that. And some of the later processors support SC2 also support denormals or 0. We're just going to assume they're both there, honestly, because it's for 64K synth. FTZ handles underflow conditions while DAZ handles denormals. Underflow condition occurs when a computation results in a denormal, and then it sets it to 0, and then DAZ fixes the cases when denormals use input, either as constants or by reading invalid memory into registers. DAZ mode sets the inputs of the calculation to 0 before the computation. So that's exactly what I suspected they would be. That's good. So FTZ bit is bit 15. And what does this say? The underflow exception bit needs to be masked. Hey, Molov. Yes, we want this combination. Bit 15 and bit 11 should be 1 in this case. Okay, so I just found a table of these bits as well. We need the MXCSR, which I think is the control register. But here we have bit 15 and bit 11. So those are the ones we need to set, and then bit 0. So that means they're 0 indexed. That's nice and easy. Then we should have a way to read these. Probably here. Load and store the CSR, or MX CSR. So I wonder if we can find an example code that will use this here. How to modify. We can read and write those. We can use fx save, but we don't want to do that because that'll save the entire state. Here, this is what we want. Load MXCSR. Okay, this actually saves out the entire state, reads it from there, and then loads it like this. That seems a bit weird. Because we should be able to load this out, or store it out rather, with this instruction. I'm guessing we can do that into an arbitrary pointer like the load actually does. I'm going to try that. So the first thing we're going to do is just see all these bits. So again, this was 16 bits. So, but I think we need a 32-bit pointer here, just judging by the type here. So then let's do this. MXCSR bits. And we'll just read those out, and then this will be, that should be good. And we don't need to mask any of this right now. And this should be, let's do this. And then we can do in 32T here. We'll do this as well. And then this will be store MXCSR into the control word. We'll do this like this. And that should allow us to read that. This will still set the FPU flags, but that's fine. So again, just looking at this text file here, we get things that look okay. And then here we'll do the we'll actually do the set here. Let's do this because I don't really care that it's not very semantically strong. The same thing here with this declaration, so we have some memory there. And then we'll do the store out into this value, and then we'll do the load. Like that. But here we want to do this. Move EAX, DWORD, pointer, MXCSR, so we can load that into EAX, and then we'll also move EAX back into that when we're done. And so here I think we want to OR EAX with a couple values here. So this will be 1 shift left 15 or 1 shift left 11. I think that'll just work. So as you can see here, the top bit was set, and then bit 11, which I need to look at this in a calculator to make sure I get the right position here. 1 left shift 11 is going to be 800, which is part of this F here. So that was already set. So I think that's okay. I think that'll set the bits that we actually need. And what I'm going to do is, let's go ahead and actually name this something semantic now. Set, what is it, flush to 0 and DAZ. Like that. And we're still good on that, of course. And I think if we go in here, we should be able to just do this globally. I believe I call helpers init here. And we should be able to do it in here. Basically that. So we'll just make sure we have int types up here. Did I call these right, or is it just FZ? Flush 2-0. I'll call that FTZ. Yeah. We'll call it that. Yeah, that seems okay. The next thing I want to do, though, is just to hack this in here. I actually want this to output that, but we'll do a couple tests first. I'm just going to run this as is. We should be okay. We actually break ABI compatibility by setting this way, but it's just going to be assumed that this is going to do what we want. Hopefully that'll be enough. Should be. Let's see. I think then we can just do this, get rid of these fixed denormal things, and away we go. I'm just gonna go ahead and delete these. And then I think we just build until it compiles. Now there's quite a lot of devices that use this function, so we're gonna find a lot of these just going through the code. But the nice thing is we just get rid of them, which is ideal. You can see how pervasive these things actually are here. Here we actually want these parens. Here we don't need them. Gonna fix that code style while I'm at it. Yeah, maybe I should use the intrinsics for those since we're just gonna OR the value anyway. But this is probably okay. That's the thing with denormals and nans, they get really, really, I want to say leaky, but I think toxic is a better word for that. think every sample of every filter is calling these functions 3 times, among many other things. I would expect these are probably in line with how small they were anyway, but it still feels a lot better to get rid of these than even have them there in the first place. The other thing, even though I've been working on this for a little while, it may be that this changes the sound enough that it's a problem. I highly doubt that's going to be the case. I will end up preparing some listening tests for the other Logicoma guys, like I did when we introduced our sine table optimization. But I suspect we'll get good results. So here, I'm just pulling up Task Manager. Look at player test CPU usage. And this should basically not explode. We're going to do some more listening tests, just listening through some songs here. To see if anything blows up. Because that's basically how the system, or how this manifests is, especially somewhere in the middle of a song like a breakdown or something, some instruments will stop making noise and then the output of that synth will just drop, or the voices for that synth will drop down to zeros. Or the problem is actually not that it drops to 0, but that it drops way too close to 0, so it ends up in denormal range, and then that just is toxic and our whole synth gets really slow. But with these flags enabled, we should actually avoid all those issues. I'm also going to want to rebuild all the plugins and test them in Ableton Live, just to be sure that there's none of those issues there as well. Hey, Chief Sector. Hey, Dascon. Yeah, we'll turn up the music. It's a really good sign, by the way. Thanks guys. It's the first track Hoffman and I ever did together with this synth. And as I've said before, one could say this is the real beginnings of Logicoma. It's us working on this track. Because now Hoffman does a ton of work on the synth as well. Like he's doing a lot more contributions than I am these days in terms of new devices and even fixing stuff and tooling for the release. And then I deal with this boring crap. Totally kidding though. I actually find this really enjoyable to work on. No worries, Chief Detector. I totally understand that kind of thing. Congrats on the new job, by the way. Malav asked, how did you and Hoffman meet and work on the song? Hoffman, so I had released an intro called Varia Part 2. No, Part 1 by Youth Uprising. This was at the Gathering 2013. And it was a really small intro, like not really much was there or happened. But I had been working a lot on the synth since late 2012, and that was early 2013, or spring 2013. And I had released that intro, and then I put an extended version of the soundtrack on SoundCloud. And Hoffman found that, and then wanted the synth, and that was it. He just messaged me. Of course, I knew his stuff. He had been a senior in the 90s under a different name, actually, but kind of came back around that time, and he really wanted to get a hold of the synth. So I liked what he was doing, and I sent him the synth, and then I think the first full track that he was putting together was this one. And pretty early on, he asked if I wanted to collaborate on it, and I, of course, didn't mind because I thought that'd be fun. And so we would just pass the project file back and forth on like Dropbox or whatever. And it was really fun, so that's basically it. And then I think we put this out September that year or so. I don't recall when exactly it was, but I feel like it was fall in 2013, but it might have been earlier than that. And then we just kept working together because it made sense. Just a couple people that are like we're really creatively compatible. Oh, that's even better, Chief Detector. I'm gonna convert a couple other songs. In fact, I'll convert the song from that Varia intro next, which is, I don't remember what it's called currently in this folder. No, it's in here. Varia, it's just called, of course. Let's convert that, and then this should work. And this song had a ton of issues with denormals. Oh, was that a pop? That's not good. Yes, that is a pop. Very interesting. We'll have to fix that. I thought I fixed these previously, but I guess I didn't. Okay. Let's just dig in then. So I'm just going to make a copy of this. First of all, actually, I want to open it in live. Make sure we're okay there. Well, there was a Varia Part 2, which is also crap. And I just did it myself in like 12 hours. In 2015, I think. There probably won't be a Part 3. VST plugin cannot be found. Okay, this opened in 64-bit. That won't do. Because these are 32-bit plugs. Where is it? There it is. Okay, so let's do... This should be the final project. I expect this might work. It might not because I think the plugins that I have built might be from the last couple weeks where I've been messing with this stuff. But I think this worked last week. So we should be okay. Oh, go here. Yeah, so it's okay in the plugins. I'm just going to do one more test before I convert something else. And what I'm going to do is I'm actually going to rebuild all the plugins, which I can just do by building the solution in this case, and it will output it to my plugin directory as well. And then I'm going to reload this song in live and see if it pops, which it should, because that'll be with the core code with other stuff. Okay, so copy's failing, which means it's live is still shutting down. It's a post-build step. Yeah, let's try just building all again. There we go. Good. And then if we open live, open that song again, we should be getting pops, which means I introduced this bug today. Stream should be okay. Don't think it went down at least. And so open that again. Huh, seems to work here. Our CPU usage looks great. Just to be sure, I'm gonna disable multi-core, which should better match the performance profile of the actual replayer, which is single core. This sound I remember giving a lot of issues. If I stop it, that's when we get the issues. Interesting. So this actually works in live. That's a bit surprising. Thanks, I'll comment, Mr. Toe. Yeah, we've had so much fun making songs with this thing. So why does this pop is the question. I think how we debug this is we do the same thing that we did before, where I make a copy of this project. Let's do varia debug, and I open that in live. And then we start muting stuff. And just figuring out what is causing this. I'm a bit surprised this caused us any issues anyway. But yeah, probably some NAND somewhere. Which is a different sentence in England. Whoops, that's the wrong project. Can you tell I was listening to a ton of M Machine at the time? Who am I kidding? I still do. Okay. So, I'm going to do exactly the same thing I did previously, where I just mute basically all these tracks till we find something that fixes this. Effectively, binary search. Let's mute all that. I'm going to save out. This is why I do a debug file, so we can make sure it's doing that. I'm also going to make sure this converts varia debug and set that as startup and run it. Okay, now I couldn't find the song start end times, which is crap, but I think we should get that with just enabling the loop. Oh, probably because the premaster was muted, which it shouldn't be. So that should help fix that anyway. Okay, the conversion worked. And do we get a pop? We don't get a pop, but it'll be a while before anything else plays. So I'll just let it play out. Okay, this is good. Yeah, so that's a good sign that it's none of those at least. And so then we'll just enable, first I'll just do some of these buses. And then we'll start enabling these. Probably one of these, like the less sex but still sex pad. Or sex ARP, that's probably what it is. We'll see. This is my classic track naming. We should get the same results here. Just gonna have to wait for the drums to come in. I could also have adjusted the start times on this, but this doesn't take that much time anyway, so. Okay, we're good. So let's just enable these first three. And I expect a pop here. No? Or did I just not hear it? Because that's weird. Oh, the melody bus is muted. That should not be the case. Sex ARP amuses everyone because everyone loves ARPs. Okay, there's a pop. And let's see, it's probably Sex ARP that's doing this. In fact, actually, now that that's unmuted, I'm going to mute all these just to be sure. And then we'll enable Sex ARP, and that should isolate it. Okay, no pop, then I'm pretty convinced it's this one. It might also be SexPad, we'll see. So, man, I am sweaty as hell. Okay, it's not Sex ARP. Probably SexPad. Still love this ARP, by the way. Okay. And then I'll try SexPad. Pop. Okay, that's what it is then. So I'm actually gonna do this. Well, actually, we don't really need to do that, do we? Yeah, this is fine. And then here's what we do. We mute all these except one. Oops. I'm also going to mute the Sex ARP because that'll help us hear it. And then we see if we hear the pad. And we do. So out of slaughter, it seems to be okay. Okay, so let's just enable 2 of these in our little binary search here. Pop already. So let's go ahead and get rid of this leveler and see if it's the scissor. And it does seem to be the scissor. That's interesting. Not what I would have expected. So if we disable this, just to be sure, we're going to hear it. And then we're going to disable it, or we're going to enable it, that is. And then we're going to get the pop again. Exactly, Superlin. The non-stop pop-pop of SSE. You know, just the fact that you call it pop-up makes me feel like you're not ready. Sorry, I couldn't resist the Arrested Development reference. Okay, so we know it's in scissor. And I'm just going to do a git diff here. Sorry about my Slack. I'll get rid of that for a sec. A lot of stuff has changed with all this stuff. Also, the whole program optimization should not be disabled there. I'm just going to go through that and fix that really quick. No, we do want that actually. Okay, then I don't know what the deal with that was. Okay, well maybe that's fine then. And skip all this crap. Actually, go to the end and work back. Should be okay there. Scissor. Okay, so this is all that changed. POW there, and then this mathematical identity, which is the same. Unless something here has changed, which it shouldn't have. Just because I'm pretty sure drive in this case was guaranteed to have a certain range here. Let's look at the code. If drive is less than 0.2, then we take 0.2 minus drive. Otherwise, it's greater than or equal to 0.2, which means we do drive minus 0.2 and we'll get something close to 0 times 5, 2. It might be, we should be able to handle 0 and negative 0 effectively here. But it's possible that this results in some crap that's below 0. And then POWF would fail miserably, make a nan. I think... Oh, we have clamp here. Or float. Let's just try something. See if this even helps. No, still pops. Which is surprising because I'm not sure what other kind of special case would make this break. And this was working before I did those flag changes and got rid of the denormal stuff, I'm pretty sure. We can double check on that by just removing this. Okay, it pops then too. That's even more interesting. Very interesting indeed, actually. Because these are the 0 checks, and those actually ignore sign for 0. I'm pretty sure. We'll turn what we need on the FPU stack. So this is very odd. Very odd indeed. If we do this, we won't get the right result, but whoops. See if that's where the issue is. I do need emotes, I need to fix that. Okay, then we hear something. So it definitely seems to be this POW here. In fact, we can... Oops. Ugh, come on. Yeah, it definitely seems to be the case. So what are our inputs and outputs here? Let's just write those to a file or something. Or probably just output them even. Okay, I am seeing some of this crap, which is probably related. Wait, I didn't see what the inputs were when that was the case. If the input was 0, we got this crap. Everything else looks pretty good, except this special case, which is really interesting because if you open the SSE shiz project, this is not the results that we had previously. So if I do POW-F with 0.0f on the input, and in this case, the exponent is 2. Okay, then we also get this crap. So what changed here? I could have sworn I had that correct here. That's really bad. Oh, I know what it is. I totally know what it is. When I converted this to let's see. When I converted these functions to just ones that I was calling rather than doing this, I had to change the calling convention. And it seems that in the case of the base being 0, it just jumps to done without loading that base into the FPU stack. So I think that's the issue here. And in that case, it's actually here that instead of just jumping to done, we need to load the other thing and then do this. So what I'm going to do is invert this, I think. It should be JNE. Yeah. Cock pow. Something like that. So jump over that, and then in this case, if we need to do this, it's going to FLDZ jump done. So it's basically the same pattern as that. And if we do that here as well, this should be exactly the same thing. And that should give us 0 in this case, which is what we want. So that's probably what happened there. And I bet I did that when changing the calling convention at the end of the stream last week. So that's easy enough to fix. If we go back into helpers and just replace these functions here, which should be exactly the same except the names. Oops, and I also want to remove that formatting. This was FPU POW F and FPU POW. And in that case, this should work again. And it does. So we're going to go ahead and remove that debug printing shit that we had. Oops. I'll just undo it away. Good. And this should work. And it does. And so then I'm actually going to close this and remove this debug file altogether and do the real one. So we'll convert that. And then we should be good here. And we'll listen to the track and check CPU as well. Okay, no pop, so I think we're good. And just watch this a bit. Looks like I've still got another console window open here. And I do, which is the old one. Great. And I'll just play through this song. We should be looking good. To be fair to Ascon, it took me a while to find that code, find bits of that code and put them together the right way. Yeah, sub 5% is really good. I mean, I have a pretty beefy CPU, but that's, like, we're never this low. I do think the SSE stuff has been faster, but I need to do some actual A/B tests before I claim that. Before I say that for sure. That's awesome. Okay. There's a couple really heavy songs, so this point is where we should get the denormal issues if they're a problem. And they're not, and that is the shit. Thanks, you super long. Hey, Dana Colin. Venguria LP, thanks for the sub, appreciate it. And it cut off a little early, but that's okay. That's just due to the converter and the way it works right now. So let's do some that I know are really heavy tracks. Backscatter is one of our heavier ones. Whoops. Need to run the converter. Hey, no worries, man. Glad you're liking them. This is probably one of the worst tracks we had as far as denormals go. You can see also CPU-wise it's heavier. It always has been. But if this were denormals, this would be like, it would jump up to 25% and that would be rip song. Danny Fritz, what sort of things can add to the CPU usage for a track, channels, effects, anything really, like anything that's doing stuff to the sound. So literally both of those things. We have some early outs, like if you have a filter that's not being used or whatever, then we're just gonna ignore processing for that. So if you change some parameters, then that's kind of a gate for whether or not stuff is used. This is still a bit high, but I think in the actual intro I pre-calced the whole music because it was so slow. It should be possible to multi-thread things. The biggest issue there is you want to just solve the dependency graph for the devices in a way that actually utilizes things well. I mean, a basic job system would work really well, except, again, it'd be hard to do the scheduling. The bigger thing there, though, is that I wouldn't want to do that in the case of an intro. It just seems like it'd be overkill. But what I have thought about is doing that in the converter. Like if we always assume there's 2 rendering threads, that we can statically determine what's going to run on each thread. But I'm not sure if that's a good idea or not. If we did per channel with a job system, it would work. But there's a lot of interdependencies between tracks, especially with sidechains. You have the output of one track might be used in several other tracks. So that's why we need like a proper scheduler if we're going to get good utilization, I think. I think it's definitely possible, though. But it's not something I've looked that much into. It'd be really easy if the tracks didn't have interdependency. So like if they all just went to the master track, then it'd be really easy. Because you could just do half on one, half on the other if you have 2 threads, for example. It's not much more complicated than that, but it's a little more. Yeah, this is 99% C++, and then there's assembler for just the stuff that I've been doing the last couple weeks. What's another? Rubik I don't think was very heavy. Actually, Reverence was really heavy. A lot of these tracks, especially these ones that we would do just as executable music tracks, they're heavier on CPU because we can get away with it. When they run in an actual intro, we tend to be a bit lighter. A lot of just listening to these songs right now because it's a good way to debug this. But I'm really happy because I removed all the fixed denormal calls and we don't have denormals. So that's pretty great. Chief Sector, yeah, more or less performance optimization. I mean, it's stuff that we need to fill in because we're using SSE rather than FPU, which in itself is hopefully a performance optimization. Like there hasn't been that much targeting stuff or like targeted perf optimization here. It's more just what do we need to actually get this running on SSE, which in itself should allow the compiler to optimize in some cases, hopefully, but also allows us to get rid of denormals and some other things. Yeah, and before AVX 512. If we do an additive synth module, that might require that. Probably not. But I wouldn't be scared to use AVX at this point for this stuff. Not necessarily 512, but that's another story. But AVX, regular AVX, I would use. Armnia port win. Maybe after the open source release, someone else will do it. So again, fairly high CPU usage here, but not nearly as high as if this were denormal problems. Yeah, I'd be interested in reading that, Dana Colin. It is totally possible that the SSE version of this code will run a lot slower than the FPU version. I don't think that will be the case, but this is why I'm going to need to do A/B tests because I won't know for sure until I've actually finished this job, basically. So I still consider this research. But we're going to really know if it's better by the time I'm done with all this. Which might be basically now, actually. DNet Vagos? Oh, that was a buffer underrun. That's not good. Thanks for the follow, by the way. Okay, that we buffer underran. That's not good. That might be a symptom of denormals, but it better not be. Okay, this is not good. This is why we want to get rid of these. So I actually want to make sure that these are what we expect when we're running. So I may do some debugging stuff loading the value of this register to try and debug this. However, it's getting late and hot. So I think I'm going to cut off the stream for today and work on this during the week. But either way, we'll see if I stream it. Maybe I will, maybe I won't. Otherwise, I'll see you guys on Thursday. But yeah, thanks guys for hanging out, and I'll see you next time.